Hello. So we tried the videos again today, but not on Facebook Live. It didn't work out so great. They're kind of all spliced together, and I'm going to upload them to YouTube. Not all the problems I talk about. So I did in the original video, but YouTube says they can only be 15 minutes long, and apparently I talk too much. So if there is a problem that you're having trouble with, snap me a picture of it. Either contact me through Facebook or Remind, and I'll help you solve it. All right. Thanks, guys. Good morning. It's AMI day 2 here. I'm kind of glad we're not at school today because it's raining outside, and I know you guys hate to be stuck indoors, so that means there would have been no recesses today. The problems today that you're working on in your packet are in lesson 10. Okay, and we're dealing with parentheses today because the parentheses tell us in our order of operations what to do first. So sometimes when we look at these, some of the problems we think, oh, those are the same. But because of the parentheses, it makes it come out with a different answer altogether. In your packet in lesson 10, the first thing that it wants us to do is to take a picture, and then we're going to write out the number sentence that matches it, okay? So when we look at this, this is 1, 2, 3, 4 boxes, and so this box right here would represent one of those boxes, okay? And if we were to add up whatever this amount is repeatedly 4 times, we would come up with the same answer as 17 plus 4, okay? So if we wanted to rewrite that, we could write it as 1/4 of, and we all know that of is secret code for multiplication. So I'm going to change it out with a multiplication symbol. And we can put 17 plus 4 in parentheses. So if we were going to write the number sentence to go with this picture, this is what it would look like. So all my kids would tell me, because of Sally, please excuse my dear Aunt Sally, that we would have to do what's in parentheses first because parentheses are the boss, okay? Now, when we add 17 plus 4, we get 21. And we keep this 1/4. Okay? So, if we want to finish the problem, we can simply multiply this out. Okay? The 21 is a whole number. So, if you like, you can put a fraction bar and then the number 1 under it so we can continue the math. And then the way that multiplying fractions works is you can first look to see if there's anything in common either in your numerator and denominator where you can take groups out, or you can look at the numerator and the denominator diagonally to see if there are any groups of numbers you can take out. As you can see here, there's not anything that we can change. So we would just need to multiply. And we're going to multiply straight across our numerators. 1 times 21, and that's going to be our new numerator for in our answer. And then we're going to do 4 times 1, and that's going to give us 4 for the denominator. Okay, so I'm going to write that down. Now, all my sweet little monkeys that are watching this, they know if they see this, I'm going to say, is this our final answer? And they're going to tell me no, that it can be simplified, meaning that it is an improper fraction. We can take out groups of 4 and write a whole number, okay? So this is going to become a division problem. All the kids know that fractions are secret code for division. So we're going to rewrite this as 21 divided by 4. And some of the kids by now, they can kind of do this in their brain and they can write that whole number down, and then they can count up to see what the numerator is going to be. So let me rewrite this as the division problem. And we all know that 4 can go into 21 5 times equally for 20. And then once we write that down, we have a remainder of 1. Whatever the remainder is becomes a part of our fraction that we're going to write down beside our whole number. There's 1 left over, and we were trying to make groups of 4. So if we were to rewrite this, the answer to 21/4 can also be 5 1/4. Okay, so if we were looking at this, the question mark answer to this is 5 1/4. If we were to add 5 1/4 4 times, we would get 21, because 5 plus 5 plus 5 plus 5 is 20, and then 1/4 plus 1/4 plus 1/4 plus 1/4 is 1 whole, and 20 plus 1 is 21. So it does get us back to our original number that we were starting with. So this is question number 1. Okay. Question number 2 looks like this. All right. So when we look at this problem now, all right, we're going to have to do this part first. This is what would have to be in parentheses here. Okay, so once we do this, we could say we have the answer to this, and we already know that it takes up 2 sections, so we could actually double it so we would know what the other section is. Once we do that, that would give us our total here. Okay, so if we wanted to rewrite this, we could simply put the 2 fractions that we're going to add together and then multiply it by 2. Now, all the kids know when we look at this, our denominators are not the same, and we did this yesterday. So we know that when we add 4/7 and 8/3, okay, that we are going to have to find common denominators. Also, you can notice that this is an improper fraction. If you want to leave it like that for right now, that's okay. And then once you add it all up, you would have an improper fraction in the end. And you saw how I changed that in just the last problem. So anyway, this is how you would start this one out here. In the next section, it looks like this. It wants us to look at this problem, 6 times 3/8, and it wants us to find the other 8 problems or the other questions that are going to give you the exact same answer. Okay, so now when the kids first saw this problem, they completely freaked out. They were really working hard, they multiplied it all out, and they were like, oh my gosh, what do I do next? But all you really had to do was look at this and say, okay, we can rewrite this several ways, but every single time this fraction, what did I say it stood for, is a division problem, right? So on every single one of these, what are we going to do? At some point, we're going to divide by 8, okay? We're going to divide by 8. So when we look at this top problem, this says 8 divided by 6 times 3, or 3 times 6. That's not dividing by 8. So the first one would be gone. Okay. This one. Now, this one I don't particularly like the way that it looks. What did I say fractions were? They were secret code for division. So if I wanted to, I could take my handy dandy marker over here and I could rewrite this as 3 divided by 8 times 6. Okay. So now when we look at this same problem, we see that we would be dividing by 8. So this is going to be one of our answer choices here. Okay, look at the next one. It says we're multiplying by something and then we're dividing by 8. So again, when you look at this one, we're doing 8 divided by 6. We're not supposed to be dividing by 6. What are we supposed to be dividing by? 8. Okay, so there are 3 of these, hint, 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 okay, that are correct. Every one of them will say divided by 8. And you really didn't necessarily have to work the problem. Work smarter, not harder. All right? These problems are all in word form. Okay? There's your magic word right there, of. What does of mean? Of means to multiply. So when we look at this and we rewrite the problem, we're going to write 1/8 times, and if you don't know what sum is, of course that's going to kick you right in the knee. Okay? But sum means to add. Okay? So when you look at this, you're going to rewrite it with parentheses because it's going to tell you to do this first and then to multiply by 1/8. Okay, just some friendly reminders there. So when we rewrite this, it's going to look like this: 1/8 times the sum of 23 and 17. Okay, now what are you going to do first? You're going to do your 23 plus 17. Okay, and you're going to exchange it down here and write your 1/8 beside it. Now, again, when you get this answer, it's a whole number. So put 1 as your denominator and then multiply your numerators, multiply your denominators. Okay, so easy as pie. We get to these questions and they are, which one's bigger? You don't actually have to work these problems, honestly. When you look at them, you can almost tell which one's going to be bigger. This one is essentially about like 15 times 1, maybe. So somewhere here, the answer is going to be close to 15. When you look at this, you have 9 plus 12 and then times 1. So when you analyze just what's on either side of the problem, many times you can go ahead and pick out what the answer is before you ever work it. Same thing here. This is 3 times 5/4 and this is 3 times 5/4. So at the moment they're the same. But then when you look at 3/5 and 3/8, the kids all know which one of these fractions would give you the bigger size pieces. If you had 5 pieces of pizza and you got 3 of them, or if you had 8 pieces of pizza and you got 3 of them. They know by now the size of the pieces, so which fraction would give you the biggest one. Same thing down here. This is 6 times 2 is 12. And then this here, okay, when you look at this, 32 divided by 16 is 2. So 2 plus 2 is 4. So this would be 6 times 4. And this would be 12 times 2. So you kind of look at it, maybe they're the same, maybe one's bigger, but you can analyze these a little bit at a time and know which one should be right without actually working the problem. The very last one gives you a chart. It gives you January through October, okay? And on question A, it wants to know 3/4 of January. So you got to go to January and plug in the number here. After you've worked all these problems, this should be easy. The next wants to know 7/8 of the amount that you would get in October and July. So there's July, there's October, add those together, and then of means to multiply. 1/8 of a pound less than 3 times May. So 3 times May, and then when you get your total, you're going to take away 1/8. Line plot. Kids should know now how to do a line plot. They're going to do a straight line. They're going to look at all of their numbers. One of the smallest ones probably is this one, 3/4. And then they're going to go all the way possibly to 3 if 3 is the largest number. They're just going to do a number line and then they're going to put an X above each one of these numbers on the number line. And then the last one, E, is add up all the fractions. So once you plug in what April and August and June is, then you can add up all your fractions and get a total. It may be an improper fraction, it may be a mixed number, but by now the kids know how to do that. Thank you for sticking with me today. We've had some technical difficulties, but I hope everybody's doing well at home. I hope this has helped maybe parents and kids. Get some rest. I'll see you after spring break. I love you. Bye.